Are you pre-calculus? Trigonometry? Oh, good, then I got the right video. Okay, so this video is for assignment A9, and it has to do with radians and degrees. So before you get worried about radians, I know that this is a topic that gets a lot of people kind of nervous just because they don't know what a radian is. So it's just a unit of measurement. Okay, so we have miles and we have kilometers, right? They're just measuring distance, just different ways of measuring it, okay? And just as you have a conversion factor to go from miles to kilometers or kilometers to miles, we're going to come up with a conversion factor to convert from radians to degrees. So the degrees that we use to measure angles were created by Ptolemy. He wanted to be able to describe to people where he was looking in the sky at constellations. So he would establish a kind of base point. I don't know, maybe north is 0 degrees. And he would tell people stuff like, turn 30 degrees clockwise, and then 67.2 degrees up, right? And so he was the inventor of the degrees, if you will, and he just wanted to be able to point to things, just as Rene Descartes wanted to be able to tell people where that pesky fly was in his room, and he invented the Cartesian coordinate system. So, that's all it is. And let's start with a definition. First off, before that, I guess, we are always going to measure angles counterclockwise from the x-axis. That's called standard position. Okay, so we can always put one on the x-axis and then rotate counterclockwise. So here's the definition. The radian measure of a central angle on a unit circle is equal to the length of the arc it intercepts. Well, it's a mouthful. But the radian measure of a central angle on a unit circle. Let's start there. Central angle on a unit circle. Here's a unit circle. Let me do a central angle. Here's an angle. The central angle is just an angle that has its vertex at the center of a circle. So we are on the unit circle and we turn theta, and the length of this curve is the radians of the angle. So instead of using a protractor and finding out how much this opens, we're going to measure this arc. And that's radians. Okay? So if this has a length of 1, notice that here this is 1, and maybe this is a length of 1, then that angle measure would be 1 radian. Okay? So let's look at this guy here. I want to think about this a little more. And so I'm on a unit circle, and let's suppose that we rotate like that. We start here, we rotate counterclockwise all the way back to the x-axis. And so we ended where we started, in other words. How many degrees did we just turn? 360, that's right. We turn 360 degrees, and yet when we go back to this definition, it says the radian measure is equal to the length of the arc it intercepts. So, what is the length of this arc? Well, it's 2 pi r, right? Circumference is 2 times pi times r, but the radius is 1. So 360 degrees is equal to 2 pi radians. Dividing by 2, we see that 180 degrees is equal to pi radians. Okay? So back on this guy. 180 degrees is right here. Boom. That is pi radians. So we have turned pi radians when we go from the x-axis to the negative x-axis, I guess. So, but now we are on to the place where we can figure out our conversion factors. And so I'm going to write what I just wrote in 2 different ways. 180 degrees is equal to pi radians. If I divide each side by 100, I see that 1 degree is equal to pi over 180 radians. Okay? If I'm going to write it the other way, and I'm going to write that pi radians is equal to 180 degrees, divide each side by pi, and we have that 1 radian is equal to 180 divided by pi. Right? So this is our conversion factors. So if we want to go from degrees to radians, we multiply by, well, look at 1 degree is pi over radians, so 2 degrees must be 2 pi over 180 radians. So we're going to multiply by pi over 180. Okay, if we want to do radians to degrees, you can see that we're going to multiply by the reciprocal of that. Okay? And so that's how we convert. That's no different than converting kilometers to miles or miles to kilometers or something like that. So I will do a few examples of this. First off, 90 degrees is how many radians? Alright, and okay, well, here's the formula. If you have degrees, you can multiply by pi over 180. So 90 degrees times pi over 180 simplifies to pi over 2. And so 90 degrees is pi over 2 radians. Hopefully that makes sense. It's a fourth of the way around, right? And all the way around is 2 pi. So that's that. Another one, how about 270 degrees? All right, 270 degrees, 2 radians. Let's do 270 times pi over 180 and 90s. Okay, so we got 3 pi over 2. So 270 degrees is 3 pi over 2 radians. Okay? Do a couple more. Ooh, 60 degrees. How many radians is 60 degrees? That's a nice one. $60 degrees, 2 radians. 60 times pi over 180. Pi over 3. 60 is right about there somewhere. This is pi over 3 radians. Okay? And the length, this is pi over 3 radians, but this is the length of this arc as well. Okay? You can see that you need 6 of them to get 2 pi. Right? Let's see. Oh, okay. How about 5 pi over 6 radians, 2 degrees? Yeah, this is, now we're going the opposite way. We have 5 pi over 6, and we're going to multiply by 180 over pi. Let's see, our pi's cancel. 30. So 150 degrees is the same as 5 pi over 6 radians. That's right here. Okay, so 150 degrees is the same as 5 pi over 6 radians. And one more, 4 pi over 3 radians 2 degrees. Okay, 4 pi over 3 times 180 over pi. Okay, that's 3, 160, 240 degrees. degrees or 4 pi over 3 radians. And so that's that. If you are having problems trying to figure out which one to do, remember that exact radian values have a pi in them, right? So you want a pi in there. If you're trying to get degrees, you're kind of taking the pi away, you're going to cancel it out. So that's how I keep that track. So for your assignment, I would like you to go to your unit sketch, and where you have all those degree labeled, also put the radian measure of them, okay? That will be the assignment. I'm going to give you another day. I'm going to ask you to label the radians on the unit circle where the degrees are labeled, and I'm also going to ask you to do some conversions from degrees and radians back and forth just to make sure you're good at it. Okay? So, you're doing good work. Keep it up. I love you, miss you. That's a fact. I'll see you later.